Thank you, Vicky, for the introduction. And hello to everyone. I mean, my CV is perhaps not as comprehensive as the other ones, and so I will try to fill in a bit of information about myself. And I mean, after hearing those great speakers and, I mean, almost seductively good presentations, I feel kind of like as complex as a potato, but I should probably not speak too badly about potatoes since I'm from Norway. And yeah, the run up to this presentation day has been, I mean, my circadian rhythm is as seagulls. But today I'm not going to present about any of that, but of an ongoing systematic review that I'm doing, which is about auditory and visual tasks that are used for functional brain, functional magnetic resonance imaging, brain mapping before surgery. So my specified problem for this one is formed as a question. So what are the implications of conveying task stimuli auditorily versus visually for brain systems involved in motor, memory, and language functions, and how this is addressed in clinical fMRI literature? So as you can see from the problem question or definition, there are at least 4 components that are important. So tasks, it's task-based fMRI. Paradigm conveying, so auditorily versus visually. And specific functions, broad functions that are typically used for pre-surgical mapping. I had too much fun about changing the background to introduce the theoretical background. But I ended up going for a typical black, clean background and a white text, like paradigm-like style. Oops. Did you see it? For the, like, as I said, few components, clinical fMRI. From a historical context, fMRI was initially introduced. When it was initially introduced, many deemed it as a potential tool for diagnosis, so diagnostic purposes. But today, the only routine application is for pre-surgical mapping. It is also used for still investigating diagnostic purposes, for example, via biomarkers and disorders of consciousness a bit as well. And it's also used for evaluating post-surgical outcome and, as has been said, surgical prediction. So for getting the necessary information to make decisions about surgery, it is important to be able to identify the eloquent areas, the eloquent cortex, or the areas that are involved for these specific functions that are important to address. And the reason why I've put the double-headed arrow between validity and task selection is because the interpretations of the brain responses that you get from tasks are heavily dependent on the task content itself. But of course, there are many other factors, as has been mentioned, regarding the data acquisition, statistical choices, and so on. So there are a few selection parts to achieve the necessary maps before surgery for making surgical decisions. And the sensory modalities that are used for conveying tasks are visual and auditory, more commonly visually than auditory, for many reasons, but of course acoustic noise during the fMRI acquisition is an important piece of that. But for conveying information in the form of tasks, the minimum requirement is that a sensory system is intact. And if the patient has an intact visual system, now has a much better offer than if the patient does have an impaired visual system. But a general goal for the task that you use and apply to pre-surgical mapping with fMRI is that they are appropriately challenging and engaging. And that is important for a few reasons, and as I can think of, perhaps especially for achieving fully engaged and good brain responses throughout the whole session. And to choose and select the tasks that you deem as appropriately challenging and engaging for the patient, it has influence on the sensitivity, specificity, and, well, clinical feasibility is about how you deem the patient's ability to perform the tasks. But sensitivity and specificity is related, sometimes used as a comparison or as comparison terms. So with concordance with other type of techniques like electrocortical stimulation mapping. But it's also important to say something about true negative, true positive, and false positive and false negatives of the results. So how valuable you see or can assess the results that you get. In terms, and that is important for the decisions that you make as well, how much you can trust what you have just detected as brain responses from the tasks. And here I've listed a few important points that you wish to achieve through pre-surgical mapping with fMRI. So one of those can be determined lateralization, and that is often done. And also to guide and inform selection of patients and planning of surgery. Detect eloquent functional areas and proximity of those regions to surgical targets. Surgical outcome predictions is, of course, a part of it, but it's not always investigated or reported specifically, and preserving patient quality of life is connected to the outcome predictions, but it's not commonly reported in literature, the longitudinal effects that fMRI planned surgery has. Okay, so this is something that I took in for giving a kind of like a theoretical foundation, or like anchoring it to theory. Task-based fMRI is, well, I can start by saying that it is not uncommon to recommend that you use a combination of auditory and visual tasks to achieve a more comprehensive mapping. But it's not always that common to do it, and it might depend, or it depends much about the patient condition, right? So how easy is it to convey information visually, auditorily, so you have to select paradigms from that as well. But task-based fMRI often follows a supermodal architecture, meaning that you are most interested in the brain responses that correspond to specific functions that you assess through tasks. And supermodal means it transcends sensory input. So you're often interested in the functions that you can detect after this primary sensory processing. That's why you use a task, and then you have a control condition that you would sometimes subtract, or often subtract. For example, you have a auditory responsive naming task for language, and then you would perhaps use tones or something like that and subtract away the pure auditory processing. And this is often communicated as modality independent, but also as modality neutral. So when you do that, sorry, I'm just gonna skip this. Can't talk myself away for days. Language, memory, and motor functions are the three broad categories that we're going to assess in this review, and they are the most typical ones to use for pre-surgical mapping. More, of course, language, motor, than memory, because as has been spoken about, it is difficult to assess it properly through paradigms. And I'm going to show you a bit about the focus of the review now. So a PICO statement is more commonly used for medical interventions, but it's not a requirement, but it's good to do both for yourself and also for getting providing an overview of what you're going to do. So then you describe the population. Here it is, patient candidates for surgery, intervention, task-based fMRI, and the comparison is auditory and visual paradigms used to measure equivalent functions related to motor, language, and memory. And the outcome assessment is of functional brain activity, and it can be many things. I will show you a bit of the categories that we are going to put the results into. As I said, it's an ongoing project, so I don't have results to present for you so far. But an article is, of course, going to come. The eligibility criteria is, well, it follows the problem definition, and it follows the PICO definition as well. So what we have included, used for inclusion criteria, is original studies reported in peer-reviewed journals, comparable auditory and visual tasks for mapping of motor language memory functions, and pre-surgical brain mapping with fMRI. So it needs to be specifically used for surgical purpose or for actually performing surgery. And the articles written in English. Exclusion criteria are reviews, as is a common thing to do for new systematic reviews. But of course, it is important that to assess that if there are some reviews that have looked into the same thing as we would like to do, then there is perhaps not that much value of a review. But so reviews are very instructing for what you would need to do or want to do, but you don't want to include them in the sample necessarily. And so what we found was that in the literature at the moment, there are no systematic review that assesses directly auditory and visual stimulation, distribution, or conveying through paradigms that are used for pre-surgical mapping. Hence, actually creating the review and not only using it for instructing further on my PhD business. Also, exclusion criteria, common one, not available full text. If you can't read the full text, then how are you going to use it? And also we decided on studies of infants and children, which is below adolescents. So it's typical to use the pediatric age, which is 17 and below. And one of the, of course, most important reasons for that is neurodeveloping individuals differs from adults. So, I mean, adult patient populations are quite differing themselves as well, but it makes at least more common ground for comparison. Also, resting state fMRI was not within the scope of this current review, and also non-clinical participants. So we didn't include any basic research, like on healthy controls that are used for instructing or guiding future directions within pre-surgical mapping with fMRI. Okay, so I know this is a lot of text on one slide, but bear with me. It is important in reviews that you are transparent about how you have received or collected the data, the sample of articles that you're going to use and assess. Because systematic reviews as meta-analysis has an important position in the field for collecting and synthesizing evidence that exists, and also many uses it for doing future research as well. So to be open about what you have done is definitely one of the more important sides, not saying that it's more important than anything else. So what I started by doing was just to kind of get myself into the topic, since I was new to it. And I started doing it as structurally as I could at that moment, to both get a kind of like a good overview of the topic and how far it stretches out. So I started by doing hand searching in broad databases, Google Scholar and Scopus, and citation searching, tracking via PubMed's related articles feature. And this is in Prisma S, which is recommended guidelines to follow. But they're not strictly, you don't have to follow the process strictly, of course, but it's good to do it. And that's what I did in the first initial period. And then I used that for starting to define some search strings that were going to be used. But, of course, to reduce the risk of bias, I involved a librarian, and I had some great information specialists in my 2 supervisors, which I corresponded with, and we deliberated about how well the search strings looked in terms of the topic. And also the librarian instructed which databases that could have been the best for the purpose. So we ended up doing a multi-base search in Medline Overall, where Embase and APA PsycInfo are included as well, or can be included in the same search. And then we ended up with 205 articles after removing duplicates. But after deliberating some more about what we could see after the title and abstract first, initial going through the articles, it did perhaps not cover what we want to assess well enough. So we ended up rerunning the search with adaptations. And it's not ideal always to rerun a search that has been properly defined beforehand, but it is definitely something that is valuable to do if you feel like you don't cover the topic well enough. So we ended up with 300 articles after deduplication of that. And this was the search strategy. So here you can just have a look over it, and it's a combination of search strings, and the slashes behind some of the words or wordings are medical subject headings, mesh words, and it's recommended to do a combination between search strings and mesh terms. And what mesh does is that you use a broad wording for a topic and for that comprises many subcomponents, and then it explodes from that and includes the most heavily used subcomponents of that word. For example, language memory. Language, it could be like comprehension, production, and so on, and that would be included in the search by using the mesh terms. And so the next step is the selection process of the articles through title and abstract screening. And I was very lucky to get a co-screener with me on such short notice. Thank you, Jakob. And the tool we used to get an overview of the articles that really contained everything, and which allowed us to use blinding. So we blinded the screening, and screening is the review of the articles, just to get that clear. So I couldn't see what he did, and he couldn't see what I had done until we took the blind off, and then we compared the individual abstract screening, and for the conflicts that they were resolved through deliberations between co-screeners and the rest of the team as well. And here is the Prisma flowchart that shows an overview of the process. So you start by identifying from databases articles, and then you go through a screening process, and the initial screening was, 293 were excluded, and here you can see the most common reasons for that. Of course, conference abstracts, excluding them is a bit controversial since they might contain some negative, unpublished results that you could want to include, but what we deemed was, since the problem definition is so specific they didn't contain enough information to really evaluate them. But we checked whether any of those conference abstracts had been republished or had been published as an article later on to try to see whether we could evaluate them on that. And actually there was one conference abstract that had been published, and that was deemed good enough for inclusion. So it's very important to actually go through the conference abstract and preprint records and so on. And so the final sample was not too big. Studies included so far in the review is 6 for the full text review, which shows that articles that directly compare auditory and visual paradigms for pre-surgical fMRI on comparable grounds, meaning they try to assess similar or equivalent function of the brain, were not many. It's not many. So there is definitely something to get an overview, good overview over. And these are the suggested categories for synthesizing results. So as you can see, we're trying to be comprehensive about what has been done in terms of participants, so patient conditions, their aims for it, which task they used, how they prepared patients for the session, and also for the measurement analysis characteristics and also findings and conclusion. So this is tentative so far, but it's more or less what we will end up evaluating the articles on. Right. As I said, the problem is very specific. So it's not going to be a complete guide on what has been done within the field in terms of using auditory and or visual paradigms, but it's going to show exactly within studies how comparable the conveying of information visually versus auditorily has been. But also, of course, for the discussion of the results, other studies who have used the same, say, for example, auditory responsive naming and visual responsive naming for language can be used for discussion, but they haven't done it in the same study. And because there might be so many variables connected to, for example, patient condition, 1.5 Tesla versus 3 Tesla used, and selection of different statistical choices and so on, it is valuable to do it concretely in the same study. But of course, these findings need to be discussed in a broader, with a broader reflection as well from the field. But that's a task for the discussion and not for the results of the systematic review itself. But it can potentially contribute to eliminate sensory modality effects of paradigms that are used for surgical planning, assessing one task version against another, provide indications of how methodological and methodical variations can impact results, and also usability of different task adaptations, which can be important for patients that doesn't necessarily have a visual system intact. And also a question in the end is, of course, what do we compare these studies on? It's single tasks, and in general, it is recommended that you use a set of tasks to assess functionality of the brain before making surgical decisions. And so that might be something that some of the studies we have included might have done. I don't know yet, because we haven't done the full text review, but it's going to be interesting to see what it uncovers. I have something more I would like to mention, and that is, for those who have both auditory and visual system intact, some paradigms are of course inherently visual and some are inherently auditory, but on some occasions it might also be good to include both. In behavioral and perceptual studies and some neuroimaging studies as well, have highlighted that combining congruent sensory information auditorily and visually at the same time can increase or improve discrimination, accuracy and precision, detection, and improve reaction times, and also provide a more complete impression of the information. So it might be something that could enhance some patient performances as well. Well, questions to future directions within the field. So I've just listed a few. There could be very many, as the former presenters have provided already. But one thing is, of course, how do you improve flexibility for individuals compared to standardizations of paradigms and other steps of the protocol? And then another thing is patient conditions differ quite much, both individually and patient conditions at populations across. So could there be an idea to use standard protocols for different patient conditions? I don't know, probably not, but who knows? Would accelerated fMRI sessions combined with other modalities, techniques be a good solution? And also naturalistic paradigms, you will get perhaps more of the social activations as well. But they do at the moment, of course, have some difficulties in terms of really making them into block designs, for example, which is what you would like to do for surgical mapping. And yeah, the last one is how well does the published reports from research reflect results in clinics? Yeah. Okay, that was everything from me.
Can you hear that? Yeah, okay, fine. Thank you. You've raised some very interesting questions, so I'm looking forward to the article for sure. But does anybody have any quick questions for Fredrik just before we change over?
Yeah,
Yes.
quick question again. Yeah, since you're the most up to date in terms of getting, looking at the literature, have you encountered? And this is out of the scope of your review, but have you encountered any of the studies comparing fMRI to MEG, magnetoencephalography?
Just in general?
No, I mean while you were collecting.
Oh no.
Okay.
But there are some studies that I've read that compares fMRI and MEG, but it's not for pre-surgical mapping.
Yeah.
But I have looked into that. But that is mainly between modality and dependency of functions versus modality-specific activations of functions in the brain. Yeah.
So still, I mean,
yeah.
It's not very popular, but I mean, because we have a competitor now coming to the, to the market, which is MEG for pre-surgical mapping.
Yeah.
So I mean, I was just curious, is it really going to compete with fMRI or not? Just to be prepared.
Thank you.